Hi everyone, welcome to class. Today we will be talking about Chapter 3, Elicited Behaviors and Classical Conditioning. Now, since you are listening to these videos, then you should have already read the chapter and you should have then completed the very first reading comprehension quiz on Blackboard. You would have seen that it's a mix of multiple choice and some short answer. Remember that Chapter 4's reading quiz will then be due before class on Thursday at 1 p.m. And if you have any issues, let me know. I will say that I did make a spelling mistake in the first quiz, so you may have noticed if you took it early on that there was a written question asking you for an example of disinhibition. And that was supposed to be dishabituation. Now, obviously, I will accept answers for both because that was my mistake. But that's why you might have been like, but Erin, that's a Chapter 4 term, not Chapter 3. Well, turns out autocorrect isn't great, so we won't be using autocorrect anymore. I will be trying to grade your exam or your quizzes before Thursday's class, definitely before next week's class, so that you guys can have feedback and know kind of what I'm expecting with those written questions so you can do even better next time. So let's now get into Chapter 3. The first thing we need to know is what is an elicited behavior, because that's really what Chapter 3 is all about. So an elicited behavior is really just any behavior we can bring forth. So it's not necessarily an automatic behavior. So if you think about, like, say breathing, we just breathe. We just do it. But an elicited behavior is something we can bring forth. Now, there are two main types of ways we can bring things forth. One is through reflexes. Now, you might be like, but Erin, isn't that like automatic? Yes, but we can cause a reflex. So that's why it's an elicited behavior. Then we've got fixed action patterns. So let's start with reflexes. So this is an automatic response, but it's due to an external stimulus. So for example, when you go to the doctor, and that classic example of the doctor like taps your knee and your leg shoots out, that would be a reflex. And that's a behavior. Your leg kicking out is that automatic response to the stimulus that the doctor is then eliciting, okay? So it is an automatic thing. You can't really control a reflex, but someone else or you can cause a reflex, okay? Other examples could include a startle response. So for me, I'm a pretty jumpy person. If I get really into something, I'm working at my desk and someone just like is suddenly right behind me because I didn't hear them come in. Ooh, do I jump? And that's a startle response. Another way is orienting responses. So an orienting response is just where you naturally will kind of turn your body or orient your body in a different way to best get a stimulus, to best absorb that stimulus. So for example, if someone's talking to you, you're going to naturally turn towards them. You're not going to turn away. Another example is, if you're listening to something or you want to look at something. For me, whenever I hear something that's like my name, I turn towards it, or something that even just sounds like my name. So my name's Erin, so sometimes people just say like errands, like gotta run some errands. But when you're not fully paying attention, it's hard to fully understand what they're saying. So I naturally turn, better able to focus, understand what they're saying, and then I'll be like, oh, they're not talking about me. And I can turn back around. So that's my orienting response that my body just naturally does. Now, the final kind of type of our reflexes would be a flexon response. And this is just where you kind of naturally pull your body away from a dangerous thing. So dangerous stuff. So whether it's something sharp, maybe it's something hot. For instance, when you're petting a cat, sometimes there's some cats you get 3 good pets in and then they turn and they're gonna bite you. And so you have this Flexion response that automatically pulls your hand away from that dangerous, sharp little mouth. Now, how does it work? Well, we've got the reflex arc. So for the reflex arc, you're going to have to think back to your intro classes or maybe a biology class where we learned about the different nerves that you have in your body. And so this is the full system that causes a reflex. So in your skin, you've got sensory systems, sensory cells, neurons, and they send what we call an afferent or a signal from your skin through your body to the spinal cord. And this is what we call a sensory neuron. So the sensory neuron will then talk to these interneurons that are within your spinal cord, and the interneuron will then tell a motor neuron to send information to your muscles to contract or relax. This will cause you to have that reflex. So for instance, if here we've got a needle, so if you prick a needle, so for instance, I've got a cactus, I touch my cactus, it's sharp, I'm automatically going to pull my hand away. And what happens in those microseconds is that needle from my cactus poked my skin, touched one of the sensory neurons in my skin. It sent an afferent signal to my spinal cord, talked to the interneuron being like, yo, that's sharp, you should move. Interneuron's like, hey, muscle, do your job. So now the motor neuron sends information to the muscle to contract and bring my hand away from the cactus. So that's what the reflex arc is. It's just this system that causes the reflex to occur. Now, the second type of elicited behavior would, of course, be the fixed action pattern. So your fixed action patterns is a fixed sequence of responses that are elicited by a specific stimulus. Now, this is a lot more complex than just a simple reflex. Now, this image I've got here is going to look very similar to what we talked about in chapter 2, I believe, where we talked about how to describe behaviors. I used the same kind of image. But what's happening with the goose here is actually a fixed action pattern. So this is a kind of natural behavior that's being caused by a stimulus that causes the goose to do this set number of behaviors, of actions. So here we've got the female goose in her nest. She sees an egg outside her nest, so she extends her neck towards the egg. She then gets up because she can't get the egg just by extending her neck, so she has to stand up, gets to the egg, puts her neck above the egg, and then rolls it backwards with her beak and neck towards the rest of the eggs. So this is a fixed action pattern. So anytime there's an egg outside of her nest, she's going to do this exact sequence of actions to get that egg back in her nest. So what is the egg then? The egg is what we call the sign stimulus, or the releaser, the thing that kind of causes that fixed action pattern to occur. So it stimulates the activation of the fixed action pattern. I have abbreviated that as FAP. I just thought it was fun. If, for example, so she's sitting on her egg, you could actually go place an egg, doesn't have to be her egg, just place an egg next to her, and you can activate her to start this action pattern. Now, one of your questions on the quiz was to come up with your own example of this fixed action pattern. Your textbook talks about dogs getting ready to play. They kind of do, front paws wide, they bend down, butt in the air, that kind of fixed action pattern. So again, I want you guys to think about what are some examples. And then, of course, there are some species-specific FAPs. So these are species-specific behaviors. So these behaviors only occur in certain species, and they're going to occur between the species. It's not going to be like cat versus dog. It's going to be cat versus cat, or dog versus dog. So here we've got two elk kind of wrestling with their antlers. And so this FAP is that they see a competing male. That's going to be that sign stimulus. They're going to put their head down in this kind of challenging, aggressive manner to be like, I will fight you with my antlers. The other animal may be intimidated and run off, or most likely they will follow suit, put their head down into this thing, and then charge. And then we get a dominance fight happening. And this is a behavior that's specific to the species. Now, there are other species that do something similar. So really, all of the like deer families of animals kind of do this, where they fight for dominance with their antlers. There's other species-specific behaviors. Again, a lot of them seem to be aggressive, but looking at these species-specific FAPs, then we can also see kind of some of the evolutionary aspects of our fixed action patterns, and how these are behaviors that aren't necessarily learned. They're something that just occurs. So these tend to be behaviors that we think of as being evolutionary behaviors, okay? Behaviors that help ensure the survival of an individual. So here, then we've got two elk fighting for dominance, probably for the right to mate with the best female, trying to ensure that the individual elk is able to pass on his genes. So he's going to do this species-specific FAP to try to defeat his competitor, therefore being the winner, and pass on his genes. Okay. So now let's move on to some of the simpler mechanisms of learning. So the first simple method of learning would be habituation. So this is the process by which we respond less strongly over time to a repeated stimuli. For this, I love to think of the example of those Febreze commercials, because that's really habituation. You've got a smell in your house, but the longer you're in your house, the less you notice the smell. But when other people come to your house, then they're going to notice the smell. So they're like, you think your house smells fine, but really it smells like this. I don't know. You guys should YouTube it if you haven't seen those commercials. They're pretty funny, and it's a great example of habituation. Now, habituation is not the same thing as sensory adaptation. Okay, so habituation is a simple form of learning, and this is through like repeated presentations. Whereas sensory adaptation, then the information's still available if it becomes relevant. Okay, so they're very similar, but habituation is more a way of learning. Now, with habituation, then we get a decrease in the strength of the response to the repeated stimulus. So the first time you walk in your smelling house, you'll have a big reaction. Next time, you'll have a smaller reaction. Until eventually you'll have no reaction, because you've learned to live with the smell. What I also think of is maybe it's a sound. So if say your partner snores, you got a new boyfriend, girlfriend, whatever, and you start sharing a bed. First time they snore, oh geez, you cannot sleep. But over time, then you'll learn to live with it, and you won't notice the snoring as much over time. You might still be, you might still know that this snoring's there, but it won't bother you as much. You'll learn to not respond to it. Okay. Now, we see habituation occur in pretty much every animal can learn habituation. And we actually was able to look at the biological mechanisms of habituation using the sea slug. So your textbook talks about that a little bit, but I just thought I'd expand a bit more. So Aplysia is the species of this, well, it's more the genus of this group of sea slug species, and it was discovered by this dude, Eric Kandel. And what we found was that it will retract its gills when pricked. So if you poke it, it's going to retract its gills. But the more you poke it, the less it's going to retract its gills until eventually it's going to stop retracting its gills. Okay. So here, if you don't like slugs, that's cool. You can think about it as, for instance, I have an older sister. I was a very annoying little sister, and I would poke my sister all the time. And at first, she would get annoyed. She'd react. We'd get in little fights. And then Mom would yell at her, not me, because I'm the baby. But then eventually, she stopped responding. So I could still poke her, and she just wouldn't even respond. And that's habituation. She's learned to not respond to the stimulus. Now, the opposite of habituation is sensitization. So sensitization is an increase in the strength of response to a repeated stimulus. So for example, with me poking my sister, sometimes then I'd poke her, she wouldn't respond, and I'd just keep poking her till eventually, and then she'd be like, okay, after a while, she'd be like, okay, Erin, stop. And then she'd I'd poke her again, she'd be like, oh my God, stop. And she'd keep going until eventually, we'd get in a little scrap. So her responses slowly increased over time to a repeated stimulus. Now, sensitization can result from repeated presentations of a stimulus, or also by arousal from an extraneous stimulus. Okay? So, here we've just got examples of habituation on the left and sensitization on the right. So in both cases, we have a repeated stimulus occur. So on the bottom, let's just say we're playing a noise. On the bottom, it's the number of noises, and then your response. So how strongly you respond. And with habituation on this left side, then you can see over time we respond less. But with sensitization, every time that tone occurs, we're responding more and more and more intensely. Okay? So here we are measuring the intensity. Now, why is that? Well, it may actually be because of the type of stimulus. So here we've got a 60 decibel background noise. So a low intensity can cause habituation. But a high intensity stimulation can actually cause sensitization. So something that is very high intensity is more likely to cause sensitization than habituation. So another thing is, now that we have this either habituation or sensitization, how does that work to other stimuli? Well, it turns out habituation is very specific to a specific stimuli. So you're not going to get very much generalization. Here, then we've got like a cat. Machines scare him. Okay, so he learned, or he, was first around this orange forklift. And then here we've got, these things are starting to grow on me. And then here he's no longer bothered by the machines. Okay? So here, then he's becoming habituated to being around different machines. But notice how all of these machines are like farm machines or something. Okay? So that's habituation. Now, if we throw in a let's say we throw in a semi-truck, the cat's going to startle again. Because the semi-truck is not related to these kind of farm machines, okay? So habituation is specific to a stimuli. You're not going to get very much generalization, whereas sensitization is not often very specific. So, for example, you can think about with, say, some soldiers with PTSD, then they get PTSD, say, in the Army. They've been around mortar shells, bombs going off, and they become sensitized to that. Now, with PTSD and with their sensitization to that sound, then they're actually going to generalize their responses to not just mortar shells now, but any loud, sudden sound. So say fireworks, or even just a gun going off, or someone slamming the door. They will generalize their sensitization to other stimuli, even though they're not related. Okay? Now, because habituation and sensitization is a very simple learning, then can these simple learning techniques last long term? Now, with PTSD and sensitization, then you can probably, understand that, yeah, that can happen long term. But what about habituation, just like not noticing something or not responding to something anymore? And it turns out that there is such a thing as long-term habituation. So with this, then the response will slowly decrease as a result of repeated stimulation. So the ability to respond will then slowly recover in the absence of stimulation. So say, again, let's think of the Febreze example. My house smells. Someone comes over, tells me, so I clean my house, and now it smells great. So the ability to respond to bad smells in my house then will slowly recover when my house doesn't smell anymore, which means if I clean it and then the next day it smells bad again, I'm not going to notice as much as, say, 3-4 days later when I've had more time to slowly recover in the absence of the bad smell. Okay? So just because you remove the stimulus doesn't mean you'll notice the stimulus is gone right away. Another thing is, like, when I'm studying, sometimes I'll put on music. And I get habituated to the sound of the music. And I'll be so into studying, I've kind of tuned out that music. I've gotten used to it. I'm not responding to it anymore. That, say, the CD ends, it's going to take me a while to notice that the CD ended, that the CD's no longer going on. There's no more music. So I'm going to slowly recover my ability to respond to music or no music when the stimulus is removed. Okay? Up next is the Coolidge effect. So the Coolidge effect is really where only a small change is needed in habituation to break it. So long-term habituation can occur, but there are ways to break this habituation, such as the Coolidge effect and then also dishabituation. So with the Coolidge effect, then it's saying that only that small changes need to break it. Now, your textbook tells the great story of why it got its name, the Coolidge effect. And what it really ended up saying is that the Coolidge effect is the enhanced sexual arousal displayed by the males of the same species when presented with different sexual partners, opposed to the same sexual partners who it has habituated. So, in the story, then we've got a rooster and a bunch of chickens. So if the rooster only really mates with one chicken, it's going to become habituated to that chicken. When the chicken's around, that the rooster's not going to get sexually aroused. Okay? But as soon as you put different chickens in the coop with that rooster, he's going to notice. And he's going to get sexually aroused again because now there's chickens he hasn't habituated towards. And so that's the Coolidge effect. Now, dishabituation is a little similar, but definitely more general. So dishabituation is where you've got your habituated response, and your response to that stimulus, that habituated stimulus, will suddenly reappear in the presence of another stimulus that seems to be unrelated. So the great example here is like you're habituated to something, something's going on, you don't notice it anymore. In your textbook, it's say you're at a firing range, and then all of a sudden there is a cutie next to you, and you're so focused on this cutie now that now when a gun goes off, it startles you. Okay, so suddenly you have a response to the stimulus you were habituated to because you have this change of focus to a novel stimulus that's completely unrelated to your habituated stimulus. So in the Coolidge effect, then the new stimulus that comes in that kind of breaks that habituation is a related stimulus. So you've got a female, you've got a chicken that you're habituated to, and then you bring in different chickens. So it's the same but different stimulus. Whereas in dishabituation, it's a completely novel, unrelated stimulus. Okay? And again, this is what I wanted you guys to come up with an example for. You could have an example of I'm habituated, I'm studying, I'm doing good with my music going on, and then all of a sudden someone pokes me on the shoulder. All of a sudden I'm going to notice not just that person, but also the song, okay? I'm going to suddenly notice, or maybe like I'm in it, and then someone's like, just is like, oh, what are you listening to? And I'm going to like jump and then notice the music and be like, oh, it's this, okay? But when I'm in it, I'm not focusing, or I've kind of habituated myself to the music that I don't necessarily notice what I'm listening to. And then someone's talking to me all of a sudden, and I'm like, oh, what am I listening to? And then I'm going to respond to it, okay? So, habituation versus sensitization. How do you know which one's going to occur? First is the adaptive significance. That's very important. So, in terms of like evolution, behavioral survival, whichever one's going to be best for the organism to continue living is the one that's going to occur. Being habituated to the sound of gunfire isn't usually good, so most people become sensitized to the sound of gunfire, not habituated. And then most people would become habituated to maybe like stinky feet or something. Rather than sensitizing, because having stinky feet, that's not a life or death thing, so you can just habituate to it. But also, after that adaptive significance occurs, then it also matters the level of intensity of the stimulus. So we kind of talked about this a little bit with the sound graph thing, that a low intensity stimulus is more likely to develop habituation. Whereas a high-intensity stimulus, you're going to be more likely to develop sensitization. So let's go back to that Febreze example. So low intensity, say it's just like, it's just garbage, a general, maybe a little musky. You're going to become habituated to that. But having cats, you smell pee, and you are sensitized to that. There's just a little bit of cat pee. Oh, you smell it. You notice it. The first time you're like, what is that smell? Huh, that's weird. And then you're like, oh, I know that smell. And then you're like, oh, crap, where is it? And you're going to become more and more sensitized to that cat pee. And again, it has to do with that adaptive significance. Now, if you have an intermediate intensity, then what happens is at first you'll become sensitized to it, and then habituation will occur. So for instance, say, you're working at, like the cat pee example again, you're working at, say, the Humane Society. First time you get there, you're going to start becoming sensitized to that cat pee, and you're like, oh, this is awful, it's so intense. And then after a while, so after maybe a couple weeks, you're going to then become habituated to the smell of cat pee. And that's because it's an intermediate intensity there. I mean, probably pretty intense with the smell. But with that, adaptive significance is going to be pretty low when you're in an environment like that. And so, pee isn't a life or death thing, so it's going to be an intermediate intensity for you. So we're going to end this first video here, and in the next video, we will move on to the opponent process theory of emotion.